This is Mrs. Moret with an explanation of the domain and range activity. It says, a mathematician says something is wrong with the shading on this graph. So mathematicians often use shading to show what part of a graph a function exists in. And so since the function starts where x is equal to 1 and ends at x is equal to 4, this line should be ending where x is equal to 4 rather than extending past. So it should stop at x equals 4. Each time you submit an answer, you have an option to share with the class. You can either do that or you can simply keep it to yourself. Here, this orange circle, I can drag it and match it up. So now the only part of the graph that's shaded is the part of the graph where the function exists. The way that you would write this inequality is 1 is less than or equal to x is less than 4. So that shows that x is between 1 and 4. And when x is equal to 1, it's a solid point. And when x is equal to 4, it's an open circle. And that goes along with the way the inequalities are written here with the equal to at 1 and just less than at 4. Looking at this graph, I notice that it begins here where x is equal to negative 1.5, and it ends where x is equal to 1. So when we're talking about just the domain of the graph, here's where it starts and here's where it ends. So I'm going to change this negative 9 to a negative 1.5 and change the negative 5 to a 1. And I've almost got it fixed. The only problem is that over here, this is a closed point. So it's not just what's above the point or after the point, but it's the point, includes the point itself. Whereas over here with an open point, it doesn't include the value right there. So that's notated correctly, but here I need to add in an equal sign. And so using this little list of inequality notations, here's where the function is equal at negative 1.5, and then it continues up to where x is 1, but it's not equal at x equals 1. So it's this option here. And you would just explain the difference in the symbols here. So this would imply a closed point, whereas this would imply an open point. This is an example of a piecewise function. It's a continuous piecewise function, but it has two different types. This looks like a circle followed by a line. Here, where x is equal to negative 5 is where the function begins, and it ends here where x is equal to 10. So that means that the x's are between negative 5 and 10, equal at negative 5, but not equal at 10. This is another piecewise function. This is an example of a trig, a sine or cosine graph, followed by a constant. The function begins where x is negative 6 and ends where x is equal to 8 and is equal at both of those endpoints. So negative 6 is less than or equal to x is less than or equal to 8. So here's another example of a piecewise function. This has three separate functions in three different parts of the graph. And I'm going to be looking at moving these shaded regions over so that they match up with the endpoints. However, I notice this first option here has a solid line on each side, and these are both closed circles. So I'm actually going to choose this one to go along with that first part of the graph. And then I've got an open circle and a closed circle. So I'm going to bring this over since it's dashed, to line up with the open circle, and then the other side of it is solid. I'm going to have that line up with the closed circle. And then on this last part here, it looks like this extends indefinitely. There isn't an endpoint over here to show me whether it's going to head to infinity or stop right there. So that would make sense that we would use a dashed line at each end. And there's the three regions of the graph. Now it's going to ask me to write the domain of this function using inequalities in the rows below. So when I look at this first region, it starts where x is -6 and it ends where x is -3. Close circles at each point. So I would write -6 is less than or equal to x is less than or equal to -3. And by doing that, I can see it totally matches up with that part of the graph with a solid line on each of those closed circle points. The next section here looks like from x is -2 to -1, but those are both open circles. So -2 is less than x is less than -1 will give me a dashed line on each end of that. And that makes sense since the points are both open at each end. And then the final section, this looks like a square root function. It starts where x is equal to 1 and ends where x is equal to 3. There's an open circle or open point at x equals -1, or sorry, +1. So 1 is less than our x, and then a closed point at x equals 3. So less than or equal to 3. And now I can see those three regions of the graph. So now we're going to be looking at the range of the function. Remember that the range represents the y values. And it says here to notice the range is y is less than or equal to 1, not just y is less than 1. And so where we see the point 2, 1, that would be like the vertex of this parabola. It would be assuming that there's not a hole in the graph right there, which there isn't. It would be a closed point. It's just that it's not an endpoint, so you can't really tell the difference. So if we were thinking, where's the top of this graph? This is the top of this part, but notice the graph extends all the way up to here. And it's an open point there, so that I need to put the dashed line there. And then down here, this is a closed point. So I put the dash or the solid line here through the closed point. And now my entire function is within this range and nothing extra. And so when I look at this, it looks like this is the top of the graph where y is equal to 2. And then this is the bottom of the graph where y is equal to -2. And so I'm going to change this to a -2 and this to a +2. And the only problem I've got here is that I should have solid lines on the minimum and maximum because there aren't any holes again. Those are solid points. And so I'm going to add in the equal sign for the inequalities. Now the range of this function. So this function is not continuous, but it does have a minimum and a maximum. So I notice the minimum is down here where y is -2, and it's an equal point because it doesn't have a hole, like this would be a hole. the open circle. That doesn't exist down here, so this isn't an equal to point. Whereas the top of the function, the highest point here, that is going to be an open circle, so not just a less than, not a less than or equal to. So the minimum value for this graph is -2. So -2. It's solid, so less than or equal to y. And then the maximum value for this graph is 6. And that would include our entire range. So this looks kind of funny to me because I notice I have all of this empty space right here. And it's filled in, it's shaded, but there aren't any functions values within that range. And so I'm actually going to make some adjustment here. I notice from where y is -2, then it kind of stops here at y is 2. So I'm going to change that to a 2. And that part should have a solid line. So I'm going to put an equal. And that looks better. And then when I look at the top part of the graph, this is for y is equal to 5 up to 6. With an open circle at each part. So 5 is less than y is less than 6. And even though there's more of the graph over here and they're kind of overlapping, all of this part of the graph is contained within this region. And within this region, there are points the entire time. So this just requires 2 inequalities. Agree or disagree? Should have 3 shaded regions for its range because it's a 3-piecewise function. So I would say it should have 3 shaded regions for its domain because going from left to right, I see it starts, it stops, and then it starts again here and stops, and then it starts again here and stops. But going through the range, I'd say it starts here, and even though there's a separate part to the right, it doesn't stop until right here. And so these 2 pieces of the graph would be in the same part of the range. And then it would start and stop again up here. So I disagree, and then I would explain that here. And that's the end of the activity.